I'm Patrick Bailey with IQlist. Today is May 18th, 2024. In this video I'm going to show you how to hollow out a Nuka Cola bottle that someone else designed using OpenScad. The wasteland is a rough place, but you can make it a little more bearable with Nuka Cola, the favorite drink of the Fallout series. For those of you who may not know, in the world of Fallout, which is a video game series and now a series on Amazon, one beverage company made so many bottled drinks that many survived the nuclear annihilation. So with Fallout's popularity, we see a lot of neat 3D prints out there. I came across one, which you can see here, that was made by Genevieve 3D on printables.com. It's a great design, but I wanted to hollow it out and give it a threaded top, kind of like twist off. So I want to do that today in OpenScad. Now first, some links before we go into this. First, here's the link. You can go, it's in the show notes for the actual bottle that we're going to use to actually remove. Now next, something in OpenScad. When you're manipulating STL files in OpenScad with the current version that's out there, you can sometimes have issues. You know, 3D images get complex, and sometimes when you're trying to mesh with them, you're trying to remove them or add things to them, it can kind of get confusing. It's a difficult process. Now, the current one, you might have issues. But what I did is I downloaded the latest Nightly Build, which as of this day is actually a newer one. But here is a link to the snapshot. You can actually go down Nightly Build. The Nightly Build I'm happen to be using is 429, and it's working great. Thumbs up. If not, you can kind of default and go to 429 2024. It's working for me right now. I'm very happy. And hopefully, sometime here in the next, I don't know what their schedule is, but once they get happy with it and life is good, I'm sure they'll release it to the public, and we'll have a much better OpenScad that's more compatible with importing STL files. And then lastly, if you don't want to do anything, I've already put this out there. So you can actually go download it as is and go print it out and enjoy. There you go, it's already out there. So with that, let's get into it. Okay, first we actually download this bottle. So you can go over here, click on the files. There's a couple of files here, but we need the Nuka Cola STL file. You can download that one. I've already done that. Once you have that, the next thing we need to do before we get into OpenScad is we need to make some threads. Now I know it's possible to make threads in OpenScad, but it's really difficult. I don't really like it. So I use Fusion 360. So we're going to make some 24mm threads to use in Fusion 360. So we'll export them as STL files, then we can import and use them. So from Fusion 360, we'll right click on here and say New Component. I like to do this because when you name these things, we can name them, let's see, 24mm, just say thread, boom. And we're going to make two different objects. And then we'll also make one, well, let's work on the first one. So click on origin so we can see that. We'll right click on that face. Sorry, not new component. Right click on that and say create sketch. There we go. And then we're going to press S for our shortcuts. I've already got some shortcuts organized, but if you don't, you can search for things. So here I'm actually using, which one tool is this? Circle tool. Let me get back in there. S, you gotta tell me what you are. Circle tool. Okay, just the circle tool. If it's not already there, you can search for things. So I'll just type in something. Torus tool, and whatever you choose, you click on this little up arrow, and it'll put it on the shortcuts. So I advise getting whatever tools you need on there. So I'll say, also in this case, circle is so common you can press C and create it. Click on there, create the center. Then we'll type in 24 because we want a 24mm diameter there. Oh, and then we're going to do another circle. And we're going to make it a little bit bigger. We'll just make it, let's say 26. Boom. Then we'll hit finish. And then we'll grab right here. We'll select this circle here. Press Q for the press pull tool. And I'll make it 200 height, which is pretty tall. You don't need that, but I do that so we can use it for other things if we need to. We don't need it for this project, but it's kind of nice. And then click S for your shortcuts again, because now we're in 3D mode. And then we'll select thread, and again, if you're not there, you have to go search for it. Click on the interface there, select modeled because we want it to be modeled. And then here we have 24 by 30, that's the number of threads per millimeter. I'm going to jump that down to 2, and we'll hit OK. So remember that, 24 by 2, so we need both to match. Now one thing I have found is that if you print this like this, you have some tendencies with binding. So what I do is I select this inner circle here. You can see the little twirling around. Press Q for the press pull tool, and I'll just do a -0.2. And you can see that pulls it back a little bit, gives a little more breathing room, and that tends to work pretty well. And I do that on both sides of the thread. So there's our inner thread. And so what we'll do is, now that we got this mesh, we'll just hit STL. That's fine. Hit OK. And I'll just save it to my downloads for now, but you can save it to the appropriate folder. The nice thing is because we named that component there, it's just easily, it puts the name right there. I mean, you can type a name in, but it saves you a few moments there. Click Save. Now we need the other side of the thread, like the bolt. So we'll say New Component, 24mm thread bolt. We're not really going to make a bolt, we'll just make the thread that you could use for a bolt. Select Origin. Gotta zoom out a little bit there. There we go. Okay, right click, create sketch. This one's even a little more simpler because we don't need the inner. So we'll say 24, finish sketch, Q for press pull, select that, type in 200, and then S for our shortcuts. And again, we'll do threads, click on that, click modeled, and then we got to change it to 24 by 2, that's because that's what we chose before. We want them to match. Hit OK. I'll zoom in here and select that little outer. Come on. There we go. Press Q for the press pull tool. Type in -0.2. Hit OK, and that gives us enough room there, and we're nice and happy. Then right click on that. This save as mesh. Same thing. Hit OK. Save again. Come on. There we go. Now we've got our threads. Now let's go work on creating the cap. Okay, so here's one that's already done, but we're going to remake this whole process. So here you can see my folder. I've got the 24mm thread. Okay, here you can see it's already done, but we're going to restart this process. So over here you can see I have a folder that has the 24mm thread and the bolt.stl file that we made in OpenScad. And we also have the Nuka Cola bottle that we downloaded that's not hollowed out. Now you can see I have two OpenScad files here. We already opened up this one that we've already created before. But here's an important thing. When you're importing information, like you can see here, I'm actually importing an STL file. If you do that, and then you run the program without having saved the program in the same folder, it doesn't know where to look. So I've had that happen to me before, and it wastes 5 or 6 minutes. So typically what's a good idea is just make this file, save it in the folder without even doing any coding, and then you'll see, you should see 4 files, these 3 plus the empty bottle cap, whatever you want to call it, in the same folder. So there you go. Otherwise you're going to have some issues. Let's get started here. So one thing I do, which actually you may not realize, there's this $FN, which kind of tells you how detailed you can go. The higher the number, the slower the render, but the more detail you can get when you're using your own geometric shapes. Now we're importing STL files, so we're going to be stuck with how detailed it is. But we're doing a few geometric shapes, so the higher, the better, but they're slower. I used to jump before, but also, when you're practicing things, lower goes faster. So sometimes when I'm doing stuff, I would do this. However, with the new program, the new nightly build I have, it's a lot faster to render, so you may not really need that. I've only been fiddling with it for a few weeks now, so I forget what the default is. I think the default's 100, but so higher is better, and if the new one's happier, then life is good. Okay, so let's comment all this stuff out that I did before, but I'll kind of leave it as a reference in case I need to cheat, because it's hard doing this off the cuff. So we'll say Nuka Cola STL file equals, and we see over there we could copy that name, Nuka Cola STL.stl. Boom. We also want to bring in the thread, so we'll say 24mm thread equals 24mm thread. We don't want the bolt one, we want the regular one, STL for this guy. Oh, and don't forget semicolon. We can run that just to make sure we didn't break anything, but of course we're not rendering anything yet. So now, let's go import this thing. Well, we'll make it a module. We'll make it a module to make our life easy. It's kind of like a little sub-program, and we'll call it Nuka Cola Cap, right? And we're not going to pass any parameters, because we'll just kind of pass things down. We'll make this pretty simple. And we'll come down here, and we'll do an import, and we'll do the Nuka Cola. So we'll do that. Now, of course, I could have just, let's just run this, make sure it works. Boom, boom, boom. Oh, well, so, yeah. Good catch there on my own part. When you're running this thing, it's a module. It's not going to run the module unless you call it. So I'll come up here, and we'll actually call the module. So we call the module, boom, now we render it, but you can see it's going to pull it in wherever it's at. It's actually way off center. We're going to have to move that in a minute. Now just to let you know, you could have imported, you didn't have to use that variable. You could have just simply done this. This works as well. Come on. And, oh. Yeah, same thing, works just the same. However, I like having my variables up here at the top because they're easier to see what I'm bringing in, and if I need to change them, I can change them more easily. Boom, and it's easier to read some code. Okay, so there's the module. Now the first thing I like to do, especially when doing a model like this, is to have the ability to split it. Oh, wait, and before I can split it easily, and then let me center this, because this is not centered very well. There's no easy way that I found to just automatically do it. So what I'm going to do to help my life out, I'm going to go make a circle. So I'll make a circle, give it a radius of 20 just to start off with. And you'll see there's that circle. I can make it a little bigger. Boom. And we want this to be, we're going to use that circle to help us, visually move this guy. So what we're going to do is we're going to come down here and do a translate. And we'll wrap this in that translate. Translate's just going to move it. And we need to move it in the X, Y, Z. And over here, you can see, did I do this earlier? Yep, you can see that's what worked before. So I'll copy that and make that a cheat, but we'll work through this. So we'll say -100, -100, and we'll see what the results are. Boom, that worked pretty well. So you can see it moved it over there just fine, but it's still not quite centered. I can click on some of these guys. Let me make this, I don't need that anymore. Okay, we can look from the top. Let's see which one's the top. I think it's that one. You look at the top, that's why I drew that circle. We can see how much off center it is. So now we can do 128. We can see it's getting there. I can cheat because I did this before, 128. And we can see we're pretty well around that circle. We can make that circle a little tighter so we can visualize where we're off. Look, looks like we nailed it pretty good. Now another thing, let's see, we'll give her that circle. Let's see how we are on the Z, because sometimes these things are not on the base, but it looks like we are, yeah, you're pretty much on there. Had we needed to move it, we could have done something like this and moved it, right? But we don't need to move it right now, so we'll leave that as a 0. Just the fact that we got it centered makes us happy. Okay, now that we got it centered, I like to do this, especially when I'm cutting things up, because I want to see what's in the center. And it's kind of hard to visualize that in OpenSCAD. There's no neat default tools like even Fusion 360 where you can just do a sectional cross section and see what's going on. So I make my own. So first what I'm going to do is come up here and we'll make some Boolean variables. Boolean's a very fancy way for saying true, false. Is it true or is it false? So what I come up here is I say split true, and I'll also say a split false. I do both because I'm lazy and I just want to comment them out. So I can just come up here and say, okay, we do want to split, so we'll make that one false. What we'll do is we'll say if split, which says, hey, if we want it to split, we're going to split it. Do it this way, else do it this way. And so we'll come, oh, let me cut and paste. I put that too high. I want to put that right down here. Gotta do those variables. So we'll take that Nuka-Cola and we'll say, hey, if we don't want to split it, we're just going to show it. In fact, if I run that right now, we'll show nothing because I'm not splitting it. But if I change this to false, we'll show, there you go. It's going to do that guy. So we'll bring that back. What we want to do is split it. So we're going to put this guy up here again. And of course, right now it's not doing anything. So we're going to end up making a difference. So we'll do a difference. In this case, I want to bifurcate it. And what difference does is difference says, hey, the first object in here, I mean, you can do a union, but the first object there, leave it as is, and then use every other object to delete from it. So I can visualize, I'll go outside of it real quick, and I'll make a cube. I'll make a giant cube. We'll make it 1,000, and I'll say center equals true for convenience. And that should make a giant cube that's centered right there. And then we're going to translate it. We're going to move it around a little bit. And we want to move it all the way up. Well, in fact, I usually we'll say I'm going to move it 500 over, and 0, and then I'll move it up 500 halfway, but I'll also go -1. I like to be just a little below the top to make these things simple. And you can see right there, it looks like it's cutting it in half. So we'll take that and we'll move that to within the difference. And for those who aren't familiar, like I just selected this, I click tab, and it kind of moves that over, that whole section, just to make it easier for reading for me. And now, boom, we've got it cut in half. Now we did a quick render, which doesn't quite look as beautiful, but if we do a fast one, a complete render, we can see we have cut it in half. And that'll help us visualize when we start actually cutting out the center. Do we really do a good job cutting it out? But then when you're done and you're happy with what you've gotten, you do that and you render the full bottle. Okay. Now, okay, last step for now, not for now, but in this, as I'm recording, we want to move this down, because right now we're just focusing on the cap. We're going to make 2 OpenScad programs, one for the bottle, one for the cap. And so we have to do this. This surface represents the surface of your build plate when you're 3D printing, and we kind of want to go all the way down. We could cut this and have it hanging up in the air. I don't like that. I want things to be properly done. So we're going to move that down. So I'm going to come over here, and I could add to this translate and just move things down like this. But because I'm probably going to reuse this code, I can wrap a translate in another translate just for how I think. So you can translate one and translate another. So this translate is centering, and this translate will be, you know, up, down, up, down. And I have my cheat notes. What did I do? I think it was 108.8 minus 100. 108. Yeah, that's not right. That's not quite right. Oh, 141.5. There we go. So we'll say 140. That gets us pretty close. 1.5. And there we go. Okay, looks like we're pretty good on that surface. But now we want to delete that bottom. So what we're going to do is we're going to take this and wrap this in a difference. And do the same thing that we did with, you know, bifurcating it up front when we wanted to split it. So we're going to make another giant cube. We'll make it big again. Equals true. So it's giant, but then we have to translate it. In this case, we know 500's above, 500's below in the z-plane, so we'll say 0, 0, negative 500, and we'll see that goes all the way down there, so that's, you know, pretty beautiful. We'll take that and put that in the difference, and should be, there we go. Looks a little ugly on the fast render, but we hit the actual render, and there we go. We have our cap, just the cap, and now we can start to hollow it out. Okay, now we need to hollow out the bottom. So we look down here. We can hollow that out with a big cylinder. So I'll come down here. We got the difference here. Yeah, we might as well. We can come down here. We'll just make a cylinder, but we'll make it big. We'll make it a height of, you know, 50 and 10 and 10, just an example. And if we do that, we should see that shooting through the top. Boom. Just like that. Okay. So, but we want to make sure we don't want it shooting through the top. So what we're going to do is we can cheat a little bit. Well, first of all, the radius. So this right here is the radius, not the diameter. And we need that to be at least 24, but we have that little space where we got that cylinder, so it should be more than 24 and less than probably 26, if I recall. And it looks like I did 12.2. So you could do 24.4 divided by 2. The nice thing in OpenScad is you can do simple math like this. It just makes life simple when you're trying to do things. And so that should give us roughly exactly what we need. But now it's too high. So it looks like what I did, through my notes here, is we went all the way to 5.7 high, very short. And that would help us get just enough in there so we're not messing anything up. But then we need to translate it. We're going to translate just a slight bit. I kind of do this to be anal. When I'm doing things like this and cutting things off, the very bottom of this is at 0. And technically it should work, but sometimes there's a little ghosting, so there's probably a 3D term for it, don't know. I just do like a negative 0.1, just making this a little lower when I want to cut. So if I do that, we should see, you see it cropping out just a little bit down there. There you go, let me do a full render. You see that just a little bit out there. And we want to subtract that, so we'll bring that within the difference. And we should, boom, we've got it emptied out. There you go. Now we need to add back in the threads. So we'll come down here. We don't need to be in the difference. We'll do an import, and we'll get that thread name. We said 24mm thread. Place that there. Boom. We'll do a full render. We'll see it should be. Oh, where'd you go? Did I name you wrong? Maybe I named it wrong. 24mm thread. .stl. Nope, it looked like you should be fine. Okay, let me go investigate why that's an issue. Okay, that was an easy fix. I had actually, in my file, I had to put an underscore in the name. It was just a name. I named it wrong. I fixed the name in the file, so now we can see we get this big old giant thread, which is a little bit too much, right? So what we're going to do is slice and dice it. So we have a couple choices here. Simple thing is just cut off the top. So let me see what I did here earlier. So we imported it, difference, yep, exactly that's what we did. We cut it off the top. So we're going to come down here, do a difference. Boom, boom, boom. And then we're going to do, I like to do the cube. Make it huge because we're going to delete it anyway. Center equals, oh, true. Boom. There we go. We're gigantic. And then we'll translate. It's going to be just a little bit. In fact, we should be probably following what we did here before. See, before we raised this 5.7, that's probably where we're going to cut off, 5.7. Let me see what I did earlier. Oh, negative 150. I just did negative 500. Oh, I cut it from the bottom. Okay, different ways of doing it. Okay, I'll do it that way. I'll do it how I did before. So what I did before, I'll comment this out so we don't see it. It looks like I moved it down. So I moved it down, then cut it from the very bottom. Another way to do it. So I said 0, 0. We'll just do 0 just so you see. So we didn't move it yet, but now if we do, negative 150. We'll see it goes, starts going further and further down. We can say negative, we've made it 200. 200 plus 5.7. And we can see, let's render it fully. We can see we got that up, and we got a little issue. I made that too thick around. So we got a problem right there. A couple ways to fix this. We'll fix it with OpenScad. Now I could go in to Fusion 360, I think I made that too thick on the outer rim. I could make it thinner, and then that's the right way to do it. It makes life simpler and easier. But in this case, let's fix it in OpenScad. So we'll do this 5.7. We'll translate, we'll make a giant cube. We'll say negative 500. Yeah, because we'll do it even on the bottom. We'll do that. There we go. Render it fully, and we see we've got that. Let me hit that to center it. Because we made our threads a little too thick. I mean, the threads themselves were fine, but we made that little outer ring a little too thick. So we need to wipe out that outer ring. Okay, so we're gonna have to come in here and make a difference. So what we'll do is we'll make a cylinder. We'll make it, because we're using, we'll say give it a height of 10, which is overkill. We'll give it a radius of 10, which is, again, overkill. So that should give us a cylinder that's much bigger than what we got. Should engulf everything. Oh, sorry. Not 10, I should say, let's do 30. Thinking backwards. Okay, so we have this thing that engulfs everything. What we need to do is we need to make a cylinder. We need to make a difference and a difference. So we're going to make a ring that if we subtracted that ring from the main ring, would give us exactly what to remove that guy. So I'll make a cylinder in here, we'll make it a 10. I will translate it because I don't like having these artifacts. So I'll make it, in fact, we'll make it 12, and we'll say 0, 0, -1. Actually, let me remove this difference so you can see what I'm doing. So I'll make it 12, and I'll make it 2020 just as an example. That's not correct yet. But you can see how that's right there. So what we did is we had the cylinder inside, which is 24.4 divided by 2. That's our biggest guy. So we can make this 24.4 divided by 2 and 24.4 divided by 2, which will match the inner ring that we removed. Oh, divided by 2. Made a mistake there. And then we'll make it just a tiny bit bigger. So I'll add a 0.1. Boom. And then we'll make a difference, which should make this outer ring. Okay. And then we'll take this outer ring, which now is one thing, and we'll remove this from this guy. So, okay. So what we're doing is we're importing this guy, we're moving it down, we're cutting the bottom off, then we're making this kind of outer ring to delete our mistake that I made in Fusion 360. It'd been easier to go back and just remove it there, and look, see, we kind of cleaned that up. And there we go. Look, we're getting everything like we want. Oh, but I see, is that our rendering? It looks like we're getting a little bit over here. You see that right there? I think we're probably not centered. And that's probably due to this right now. Let me see, 0.2. Let me just move it slightly. Oh. Let's see. +1, so exaggerate it. And we see how that moved the whole thing. Get a little cleaner. But not quite enough. -0.2. Oh, yeah, now we're moving that over there. So we got a little issue there. Are you okay on the back side? Let me see. Very, very subtle, right? Then we gotta move that. Okay, how are we on the back side? Oh, much cleaner. Okay, we cleaned all that up. It looks really good. And so now we've got our cap, mostly, but there's still one thing that I need to tweak. In my opinion, I love the model. I think it's a great job, but this lettering up here doesn't need to be that high. So we're going to chop that guy down. So now we have all this beautiful stuff, all these things, and we're going to do a union to make all of this one object, to make it simpler to do a difference. So then we'll do a difference around this whole thing, and we're going to chop that top off. And so I'll come down here and we'll make a giant cube again, say 1,000. Doesn't need to be that big, but that's just my habit. Okay, so we'll make that thing, it's gigantic. We're going to translate it. Zero, and then we'll raise it 500. If we raise it 500, that's going to make it just even with the floor there. We need to go a little higher. So 500 plus 6, which is not enough. But now we can actually see, we're actually seeing a little bit of our guy. So we'll take this as is, put it in the difference. Boom. Boom. And now we can see we've got our cap, but we give it a little bit too much of a shave. So we'll raise that a little bit higher. We'll say +7. Oh, there we go. See, we're seeing a little bit of that lettering. And let me see what I did before. 6.9 plus 0.8. Okay. So pretty close to what I did. So 6.9 plus 0.8. Whatever, that's pretty close. So 6.9 plus 0.8. Oh, I know what I did. Here's what I did. Watch. Watch. Or I think I did. Maybe I didn't do that. We'll do 6. So now imagine, this is what I was thinking, but maybe the files have changed slightly. Imagine we go to where we're barely seeing that. So we just barely see that, right? Like 6.6 is probably correct. 6.65. 6.8. Okay, we barely see what's going on here. Oh, this is one we had an issue, didn't we? And then once we get where we want, then we add on what we want. Oh, I had to do this twice, didn't I? Oh, it's been a while. If this was what, I have an issue, we'll walk through it. But if this is exactly what we wanted, and we wanted to do like 0.2 layers, now we can say, you know what, I want to do 0.2 layers, but I want to do 4 of them. That's what I was thinking. And there you go. Now you've got this guy. However, if I recall, what did I do? Did I do this? I will go double check. Did I cut this and move this? I'll have to do a double check. I think we're okay with this. But if not, I'll do a double check. Okay. But then you're going to get 0.8 layers, and that might be exactly what you want. So there you go. Render it. Save it. We've got our cap. I'm 90% sure. If not, I'll tell you what. Well, I'll go double check, and I'll tell you what I'm thinking. Okay, I was mistaken. It's all fine. What I thought, there might have been a layer here in the lettering that there was nothing. Like there was an empty space. In which case, I had to do a lot more work to cut and paste and reorganize this. But it's all fine. I mistakenly in my brain thought there was an empty layer, but there is not. So there you go. Life is good. So now let's go get to the Nuka-Cola bottle, which we will use. We'll copy some of this information over, like our translates, because we want to center it in the same place. But it's going to be some different work. So let's bring in the full bottle. I'm going to do this without the cap. So here we import the stuff. We got the bolt thread this time we want to import. We're using the split again. Oh wait, we didn't show off our split when we actually made something cool. Let's go back here and say, okay, let's split it. Doom, doom, doom. Do a render, and there you can see it all split. It's kind of nice to do that sometimes. You can kind of see, did I really get things where I wanted to before I was done? So again, split, and then when you're ready, save the STL file so you can get ready to print it. Okay, back at this. So we render this guy, and we've imported it, and we all set it up. Life is good. And so the first thing we need to do is do a difference, because we want to cut off that top. Okay, so we'll make a big cube again, just like we've done in the past. Center equals true. Boom. And we'll translate it. Come on. Come on. Okay, 0, 0, 500 gets you to even. But then we want to see, what did we do before? Plus 138.8. Okay, 138.8 is what I chose. We should see that gets kind of up there. And let's move this to within the difference. And run that guy, and we'll see we cut off our top. Now I think I chose that spot because it's kind of right there on those edges. Technically the other one was a little higher, but I don't want that nub. That's where my threads are going to be, right? So I kind of, I adjust like I want it. But now we're not empty, so we need to empty this guy out. So here comes the fun. So what we're going to do is we will, boom, boom, boom. What we want to do is we could create a cylinder. You create a cylinder, it'll go right through there. In fact, let's do a little cylinder right here. This is not the way to do it. We'll say, go 200, go ridiculous height, and go, 10 and 10, just to cut something out, and boom, you will see it. Of course we would translate this to be a little higher because we don't want to cut a hole through the bottom. But if you did that, if I split this, you're not going to see what you want. You're just going to see, one hole. Okay, that might work for a prop, but also you're going to 3D print all this, so you don't need to, you know what I mean? Well, I guess you got to translate. You'd say translate. Go, let's see, 0, 0, and let's make it 10 on the bottom. And then, you know, if that worked for you, fine, but you know, that's not kind of what we're aiming for. So let's not do that. We want to create a unique shape that will represent what's inside here pretty closely. I'm not going to do perfect curvatures. I'm just going to do some simple lines and get the job done. What we can do is we can make a shape and then basically rotate around an axis and then move it up there. So let's show you how to do that. And we're going to use polygon points. So I'm going to cheat a little bit and kind of copy these polygon points. So down on the XY plane, you can basically say, hey, I'm going to make a polygon. It can consist of a bunch of points. And you put in, within the brackets, you put it into individual brackets for individual points. So at the point 0, and then whatever 8 divided by 1.45 was. I did that because I made something 45% bigger, and I was making a big one, and I was just kind of copying the code over. Which, you know, that's sometimes convenient because you can do math here. So let's comment out the bottle so we can see what we're doing here. So you can see I kind of made a shape. And so all these points, in fact I could remove one, see if I can comment out this point. Well, see, that point was actually right there, and now that we remove that, the rest of the polygon is like that. So you can fiddle with these points, and these points will get you this 2D object that we intend to render, and also you see I left a little gap here. Now, the funny thing is, you're like, well, why should this be in the Z-plane? Well, because we're going to use the linear extrude program. Now, the linear extrude program, you can take something like, let me come this out for a second. I'll take a circle. Take a circle and make it 20 down there. So there we go. But we are splitting it. So let me stop splitting for a second. Okay. Now there's a tool called Rotate Extrude, which will take things in the XY plane and rotate them and extrude them, kind of like a reverse, not a milling machine, what do I want to talk about? But basically kind of rotate that around. So I'll say a linear extrude. Now this will not work due to something. So, oh wait, it did work. Oh, maybe they made some fixes. Okay, maybe I am mistaken. I thought it wouldn't linear extrude unless you're on one side. Okay, well let me make a square. Square 20. Oh, I'm doing linear extrude, sorry. See, rotate extrude. How about, yeah, linear extrude, no doubt. Forget while I'm doing it, right? So I'll do a rotate extrude, and that should fail. Yeah, it fails, perfect, because that circle, it needs to be on one side or the other. I think it's, so I'll translate it. Is it just one side or the other? We'll try. So what I can do is I can say, okay, I'm going to move it -20 over, and then now that should work. So what that did is that moved that circle over, then rotated the whole thing, so it kind of made a little donut. In fact, if I do a -40, you'll see it a little bit better. So what it does, we'll remove this rotate extrude for a second. It'll take this circle, rotate it around the y-axis and make that donut. Then once it's done, it's going to flip that at a 90-degree angle, and you get what you get. And if I do that, we end up making this donut. Now, we'll do it the other side. I'm doing it on one side, but I guess that'll probably work too. Yeah, I guess that works too. You just can't have it on both sides, right? So, back to this guy. So we have this special shape on one side, and then we'll do a rotate extrude. And we're going to rotate that guy around, which will kind of give us roughly the bottle shape we want. Now you can spend more time getting it better than what I did, but there you go, that's roughly kind of the inside. So now let's bring our guy back here. Boom, boom, boom. And we'll see, we're spitting it out here. And we'll do a split so we can actually see what the heck we did. And if I do this, well, you see nothing happened because we're actually not doing the difference. So we'll grab this, and we'll place that in the difference now. And boom, there you go. Now we've got our cavity. So, you know, it's not perfectly smooth and rounded. You could really get crazy if you wanted to. You could get all kinds of little things. But that's more than enough for 3D printing. It makes me pretty happy. So, we got that. Now we need to add the threads on the top. Okay, now let's add in that thread. So we're coming down here and do an import. And we'll go find our bolt thread that we intend to put in there. And of course it's going to be really, really long. And look at that. Oh, well, I don't need to split it now anymore, do I? Let's remove that split. Do a full render. And we see we're kind of choking that out a little bit. So let me see, what did I do last time before? What did I do? I moved it up and then I cut it. Now this time I'll move it down. Okay, so what I'm going to do is I'm going to move it down. So I will, oh, and we gotta hollow it out too, because right now this is totally solid, and that's going to be, you could thread it on, but then it would be solid. What's the point then, right? So we'll translate, boom. And we'll say 0, 0, negative 40, just to start off. And so we'll see, we'll go down a little bit. If we look at what we did before, 60 divided by 1.5, what was I doing? 147 minus 2.5. I was doing all kinds of fun math stuff, huh? I was cutting that top off. Okay, I see what I was doing. I was cutting the top off. Well, we'll do it the opposite. I just kind of feel a little opposite now. Now, I remember tweaking this a little bit, going back and forth to get the exact height that I wanted. In fact, I printed out some examples to make sure that the cap was on there pretty well. Like, that's probably a little too high. So in this example, I'm probably not going to be very precise with what I'm doing. 57. But I would fiddle with this to get exactly how I wanted. But of course now it is still jam-packed in there, and we need to, like, if I split this up, let's see, let's split it up. You'll see it's kind of filling all the guts up right there, right? So we'll do two things. We're going to have to do a difference. So we'll do a difference. We'll bring back our old friend, the giant cube. Boom. Okay, so it's a cube, 1000, center, equals true. And we'll translate that. And we will say 0, 0, well, negative 500 gets us down to the bottom. And we'll say plus 50, like that. And you can see we cut a bit of it out. Yeah, not quite yet. So we'll say 140. A little too much there, right? So we'll say 135. There you go. We're kind of getting there. And the next thing we're going to do is we need to actually cut a cylinder. So we're going to have to put a cylinder through this whole thing. We'll call it, we'll just say 200, 10, 10 as an example. And if we run that, we have this giant cylinder. Let me say it 5.5. Okay, 5.5. Boom. And then we'll do a difference. This is not quite what we want, but we're close. Boom. So we cut that up. But now we want to get that precise, and we know we cut this out with this guy. If we go look back and look at what we did here, it looks like I went out 8 divided by 1.45. So I can do that again, 8 divided by 1.45, so that I can get that precision I want. Oh wait, because this is a radius. Okay, so, this is a radius, it's a diameter. Let me multiply that by 2, so I can be right. 2, am I thinking incorrectly? Nope, I'm doing my math wrong. What did I do? Okay. Or is it 14? Ah, must be 14. 14. That sounds about right. Okay, sorry, I was looking at the wrong one. So 14 and 14. And then we're matching that, and boom, we got that perfectly. Remove the split now. And we can see now, boom, we've got our empty Nuka-Cola bottle with the cap. And we can render this, save it, and now we've got both of them. Now what I suggest you do, if you were going to, well, I mean, we already have the file, you can go download this, but if you want to do this for fun, to learn it yourself, go do some test prints. So go bring these both in, and then pull them down, so you're only printing the top of this, and you can test that bottle before you commit to printing the whole thing. Gone so long. It's been a long while since I posted anything here. A lot has come up in my life in general over the past few years. I hope I can get back in the fray and start making videos again. In fact, I've been working on trying to make a useful short every day. And man, so much has happened in 3D printing in the last 2 years. I think the biggest change is the vast improvement in 3D prints available out there to print. And I see lots of multicolor prints starting to come of age. At any rate, until next time, work hard, innovate, learn, and never be clueless again.